Hi friends, welcome to 1 Minute Math. Today we're going to do a speed run of finding maxes and mins of functions. This would be an AP Calculus or Calc 1 topic, a very classic application of differentiation and derivatives. If you want the full explanation of what all these words mean and where these concepts come from, click the link in the comments and watch the full-length explanation. This is just going to be the quick how-to. All right, so let's say I get this problem. Use analytic methods to find the extreme values, maxes and mins of this function. So I've got a function here. The first thing I'm going to do is find f prime. Just using the power rule here, minus 12x plus 9. I need to figure out where does f prime equal 0 or f prime does not exist. Those are the two places where I might have maxes or mins. So now my spidey senses kick into gear and I'm like, ooh, this looks like I can factor it. So I'm going to go ahead and do that. And when I factor out a 3, now I can factor this as x minus 1 and x minus 3. So I've got what we call critical points. Critical points or critical values are the x values here called 1 and 3, where f prime equals 0 or does not exist. So it's just a polynomial. There's no places where f prime does not exist, but there are places where f prime equals 0, and they're happening at 1 and 3. So now I'm going to examine f prime on these intervals in the number line. If I plug in a very large number, f prime will be positive. If I plug in 2, f prime will be negative. And if I plug in a number less than 1, f prime will be positive. Again, I'm speed running this. You can evaluate those in your own time. So my conclusion here is that the behavior of f is increasing, then decreasing, then increasing. And I can see that there is a local max at x equals 1 and a local min at x equals 3. Are they global? Maybe. I mean, I know that they're not because I understand what the behavior of this function looks like. It's not going to have global maxes and mins, but I at least know that they're local, and it's okay to say local even if it ends up being global. I can call these things relative maxes and mins even if they're absolute. Now, I will point out I'm not 100% done with this question because it asked for the extreme values, not the x values where they occur. I did not say local max equals 1. I said the local max happens at x equals 1. So now I've got to actually plug those numbers back into my function, my original function, to find the values. F of 1 is 5 and f of 3 is 2, so the local max equals 5 at x equals 1, the local min equals 2 at x equals 3. Fantastic. Last part of this problem. Let's say you get the same problem, but instead of just saying find all the maxes and mins, your teacher says on this closed interval 0 and 5. So now you would start this problem the same way. I'm not going to redo it, but you figured out that x equals 1 and 3. But now we've got to consider that the endpoints of my domain might also be where an absolute max or min occurs. So the endpoints of my domain, 0 and 5, as well as any critical points that I've found, I'm going to put those all on this chart and call this a candidates test. I have 4 candidates for where a max or min might occur, and it's these 4 x values. So I got to plug them all back into f of x. I already did these two on the other page, so you can go back and check my math. I believe this is 5, but I feel the need to double check. 1 plus 9 is 10, minus 6 is 4. Oh, it's actually 6. Might be. I have to change that on the other problem. And when I plug in 5, we get a number 22. And again, you can plug that in on your own time and double check my computation. There is a smallest value on this chart. It happens twice, but the smallest value, the absolute minimum value of this function is 2. There is a largest value that happens exactly once, and that's 22. So the absolute maximum value of this function is 22. It doesn't matter that one of them occurs twice and one of them occurred once. It doesn't matter how many times the absolute max or the absolute min is achieved, it's still the same value. And then from our fence post analysis, from our number line analysis on the other page, we already had concluded that this is a relative max. So you got to use both the f prime signs. Is f prime positive, negative, 0? How is it changing? And the values of f if you have a closed interval to determine whether which points are your absolute max, which values are your absolute max, which values are your absolute min, as well as classifying those internal critical points as being relative maxes, relative mins. I hope this was helpful to you. Again, click the link in the comments if you would like to see a full explanation with some more examples. Thanks for watching.